Hello, thank you. Test, test. It's working? Very good, thanks. Yes, yes, I'm working for WizardSardine most of my time. We love hardware wallets. I will go back to that later. The title, yes, is maybe like a big title because HDBY was like a very good work done by Ava and other maintainers, other generally Bitcoin Core maintainers. And yeah, I'm not a hardware engineer. I'm a software engineer. So hardware, I only know it by using them and playing with their interface. But I don't build them, and I know one thing for certain, that hardware is hard. The hardware wallets, if you don't know, is this kind of little devices with generally screen or not screen. This is my personal collection thanks to WizardSardine, so I have a lot to play with. The key value, I mean, the pros for hardware wallets are the isolation. You want to isolate your keys from your laptop or your mobile because in case you get compromised, your keys are always safe in these little devices. You have a lot of flavor, a lot of new hardware are designed and built every year. So I just showed this one, but there's a lot. And yeah, I'm very happy that Snap is building on a new one, a new toy for me. Yay! Yeah, it's like I don't want to advertise too much hardware wallet because it's really depending on you, on what you need for your usage, on what is your personal threat model, and there is a lot of drawbacks to hardware wallets. Just the elephant in the room is it's a dedicated device for Bitcoin, just like a big target on it. And say, okay, maybe a supply chain attack on this kind of device could be really valuable for attacker. Personal security, you know, we have this little breach in France where a lot of consumer information was leaked from one of our main hardware wallet manufacturers. So now people get a lot of phishing scam on emails. We rely a lot on the manufacturer to not do a backdoor in your device, to have like a proper software security. And as I think Lloyd explained yesterday, even that you're not aware if, for example, there is kind of X-file going on in the background of your hardware. And of course, price, maybe just it's not enough. All this, the isolation is not enough to make you buy a new device. And it feels like every year you have to buy a new one. Like it's like some drawbacks that generally people are like, oh no, I don't want to invest too much. And yes, it's easy to spot. This month I crossed several borders with hardware wallets with me to do demo of Liana or wallet product. And each time I was like very stressed when I crossed borders because like the border guy can just see that I have hardware wallets and say, hey, you have Bitcoins, so just go with me in the dark room now. Security of hardware wallets, yeah, hardware wallets always depending on your threat model, so I will not too much elaborate on that. Sorry if you wanted me to have big arrays of every pros and cons for each device, but I will not do that today because I want to talk more about software. So yeah, the threat model is really depending on you. A lot of, I mean, some hardware wallets projects are able to mitigate the previous cons by doing open source and with generally common components that you can find in a common hardware store. But if you want a real security against a key extraction attack, generally you need a dedicated chip named the secure element. So it's something that you generally find in passport or banking card. And yeah, it's generally the best if you want to not get your key extracted. And of course, trust is always required. You trust that the device that you receive is genuine, that there was no tamper, no evil software in it. So yeah, security is like a big deal, and you have to mitigate this. And so another thing about our wallet that I just want to highlight, Kevin yesterday said signing device. I hate this name. Hardware wallet is not a signing device. Hardware wallet is even the worst name because you have the wallet name in it, and for newcomers, it's very weird because you have Yellow wallet, Sparrow wallet, and then hardware wallet. So it feels like, what is a wallet in the end? So naming is very bad. Signing device is bad. It's a verifying device. Verifying device because what you should do with a hardware wallet is not just press and sign, is to verify that the addresses match the one that you expect. For example, how can you be certain that your transaction, that the change output of your transaction correctly goes to a change address? You can try to, I mean, if the idea is to have isolation, why do you want to trust your laptop or your mobile to say to you that the change address is correct? You want your verifying device, your hardware wallet, to, from the secret, do all the derivation, use the descriptor. Generally, you will have like a miniscript descriptor or a multisig descriptor with it, derive from it, do the script and check match against the addresses and display the result to the user. So, from all these cons, I think with WizardSardine, we think that with multisig, you can have all the, you can mitigate all the problems of hardware wallets. If you don't trust enough one provider, you can have multiple providers and do multisig with them. Of course, multisig has a lot of trade-offs. I don't want to elaborate too much on that, but you know that you generally people use a weak threshold because there is always a key that gets lost, or you have this problem of not backing up correctly the public key of other members, so you lost in the end the overall descriptor of your funds. So multisig has a lot of drawbacks, but we think it's the best way to use hardware wallets if you want to spread. If you want to mitigate the risk. So at WizardSardine, we think that multisig is mostly solved now thanks to miniscript. With miniscript, you only have one descriptor file, and you can have multiple recovery options with your multisig. For example, as a primary spending policy, you will have a 2 of 2 multisigs that can become a 2 of 3 after 1 year after a time lock. And since 2020, we worked a lot to have miniscript integrated in all our Bitcoin ecosystem. We integrated it in Bitcoin Core. We encouraged standardization like BIP 388 and other BIPs, but I don't want to talk all about that. So because we love hardware wallets and we want to have multiple ones with multiple brands, we kind of need a common interface for them. Why a common interface? Just one thing about miniscripts. One of the reasons that we built Liana Wallet after 2 years working on the Revolt was because at the time, back in 2020, there was nobody were supporting miniscript. All the hardware wallets were not supporting it. So we had some kind of chicken and egg problem where we asked manufacturers to integrate miniscript, but they didn't want to do it unless there were users. And users were not interested in our product unless we had security options like hardware wallets. So we went for 5 years for an harassment campaign, and yeah, so a famous brand that still did not integrate Miniscript. But today we have like 5 or 6 hardware wallets brands that support Miniscript, so we are very happy to suggest them to our users. So why a common lib? Yeah, the idea is to abstract and simplify hardware wallet integration for the developers and reduce our dependencies by having a common one. And of course, nudge a little bit the hardware wallet builders to follow the standards. We have different implementations. The most famous one is HWI. It's one in Python. Async-hwi is one that we started building at WizardSardine for our own use case. It's in Rust. And there is, I think it was a few months ago, Lark, released by Sparrow Wallet in Java, that allows you to talk with, I think, a lot of devices. And yeah, to speak about these libraries, most of them, I mean, I think it's to change the word, but my idea was with async-hwi, we hit like a wall when we wanted to have like multiple components and giving more tools for the developer. And it feels like if each language must have a new implementation of all the interface, it feels like we're reinventing the wheel each time. We redo, again, development implementations instead of having just one that can take the lead on all of them. So I'm working now on a new library called the Bitcoin hardware wallet interface in the lake of a better name. And my idea now is to explain to you how I what was my approach to this kind of library and why I did it. So I just wanted to show you like a typical flow that you have between a client, a hardware device, and a user. So you can see that there is a lot of back and forth, and there is comments that are sent to the device, and the device generally waits for user input. You see that generally devices need more information in order to do proper verification. Like we do the command to register a descriptor, so the hardware device is able to do the correct derivation and is able to display the correct message saying that your funds are going to the right address. So in the first flow, you can see that the hardware device just display to the user that is sending 0.1 Bitcoin to address 1 and 0.9 to address 2. And the user don't understand why there is 2 recipients for transactions that supposedly were sending only 0.1 to 1 address. It's just only because the hardware device did not have register the descriptor, so it's not able to do the derivation of the change address. Generally, the indexes are stored in the PSBT BIP32 derivations field. And there is no currently option to add to the PSBT descriptors to it. So descriptors are another piece of information that you have to load in the device alongside the PSBT. So if we're working in Rust, we certainly have some kind of interface like this one, HWI, where you have multiple commands, and we should expect that every brand try to implement a Rust library, a Rust module that will implement this interface. A communication between a client and a hardware device generally has multiple layers. You have the data API format, that is the normal one. And you have the encryption layer. Some hardware devices don't have it, some of them have. And you have the transport that can change. It can be Bluetooth, it can be USB. Even maybe QR codes, but QR codes are like very, very complicated to have when you have to register descriptors on very large PSBT. Why I showed this schema is just because to understand that we want our interface to be generic across multiple transports. And finally, the only thing that does not change is the encryption layer on the format, the encoding format of the hardware wallet API. So a developer generally will I think it's what I did. The first time I developed a library, I just put the transport as a generic to my struct. To my device, and I just switch the transport either Bluetooth or either USB. But you can see that at the heart of the command, you have the I/O, the transport that is embedded inside, which is a shame because what about async? So if some of you don't know what is async, async is a nice way to handle I/O, especially in Rust, where you can have proper cancellation, propagation, concurrency, safety, and resource management. A lot of new languages now support new async runtime. Our way to do it, like Zig just came with a new proposal, I think a few months ago. Of course, async has its own drawbacks, like the function coloring problem or the lack of stable ABI for async Rust. It's just sad to think that, okay, async is very great, especially if you want to have cancellation. Cancellation is important when you don't want your software just to be blocking on waiting the user input while you have more resources that can be managed somewhere else. So why not do something called sans I/O library? Sans I/O library is this kind of interface where you separate your command and your response methods. So you do like a nice sandwich between your I/O when you send and you receive. So great, we have this kind of sans I/O library that now can be used with blocking methods or asynchronous method. Why not then go to, I mean, did we fix the problem? Not really. I mean, at the end, you have something like this. So you could implement like your bhwi for your device where you have the nice sandwich between your blocking method, or you have the async bhwi for your device where you reuse your method and you just integrate at the heart of the method the async. No, we have a little problem. For example, Ledger. Ledger do a nice thing to have a smaller memory footprint on the device. What they do is instead of having the whole information loaded in the device memory, you commit your information at the beginning of your exchange with Merkle root hash. And each time the device needs more piece of information, you have to provide it with the Merkle leaf proof. So it means that you have a lot of back and forth exchanges between the client and the ledger. So if we do like a sans I/O kind of stuff, we'll have to multiply commands, and we have to think that users, developers, the users of your library, have to implement, like, do all the exchanging in their code. And it's not really what we want. What we want is to abstract all of this for the developer, so you don't have to think about comments, response, where are we in the state of the exchange. So what we really need is what we call the interpreter. So the interpreter just does a nice sandwich, but it will keep in memory the state. And it will update itself on new exchange from the device. Like the device asks for a new piece of information, the interpreter knows the historic of the exchanges, so is able to answer. The developer just have then use the interpreter of the device and can call it in is in code like in this way, where as long as the interpreter receives data and manage it, the loop continue. And when the interpreter said, "Okay, we are done. I got the final response," the loop can stop, and the response is yielded. So now that we have this idea of interpreter, where for each device we could design an interpreter, there's another thing that we have to take into account. Jade. Jade has something called a pin server. The idea is they didn't have a secure element in their software, in their hardware. So the idea was to use like a third party that will keep an encryption key and that will help to decrypt your key on the device memory when you need to use it. And it enforces policy against brute force attack. Like the ping server will refuse to unlock the key if the user did fail to enter the pin code for 3 times in a row. So it means that now we don't have just three participants in our exchanges. We have like a fourth one. And it means now that our interpreter is kind of what we call the router. It will route information either from a recipient to another one. And that's the final design I was thinking about for this new bhwi library. Is like this kind of interpreter for each device. We will implement this different interpreter with different recipients, of course. For most of them, it will be only between the client and the device. But for some, like Jade, you will have like a recipient with your pin server. And the developer just have to reuse the interpreter and is able now to, from a package of information, to understand what it is required from him. It also means that the user, the developer now, is able to use his own HTTP client as he may wish. And it's particularly useful if you're working on a WASM integration, because WASM, for example, you don't have HTTP request done by your code. You have to delegate it to the fetch API of the browser. So the end game, each device its interpreter, a common interpreter wrapping them all, WASM library, and of course, because all our comments, all our methods are normal methods, it makes bindings way much easier. It also means that if you rely on your, let's say I'm doing an application for on Kotlin to support to have like the bhwi library, it means that I can use the Kotlin IO library inside my app and just use the Rust bindings to do the interpretation of each document on the responses. And I'm working on it sometimes. You can see that I didn't move the things for 5 months. But maybe we'll find some more time to work on it, and maybe one day you will use bhwi if you like it. Yeah, questions? Yeah.
Does it support music?
Well, music will be supported by the PSBT format. So right now the library is in Rust, and the Rust library does not support only support music too in the crate SecP, but the Rust Bitcoin does not have the PSBT yet. With music to fields and the Rust miniscript does not have yet the music to fragment.
Right, those fields are pretty easy to add, but that's all you need then, because the music 2 also has a few other messages probably with the device.
Oh yeah, So it would be interesting to integrate in the interpreter this kind of comments when you reroute the new information each time. Yeah. But I didn't work yet on music too, and yeah, maybe it should come. Yeah.
What devices does it support?
Sorry?
What devices do you currently support?
On the async-hwi supports the 4 devices that have a screen on MinScript right now. So by that I mean Ledger, Jade, Spectre, and Bitbox. But for bhwi, I only started it like 6 months ago, and I don't work it full time. I only support Ledger, Jade, and I think Spectre. But yeah, I really want to work on Bitbox too. I have to find time. It supports Coldcard too, I think. Yeah, Coldcard, yeah. Thanks. And for now, what it does, for now, it's only fetch Xpub. But you can fetch Xpub now in a WASM runtime. So I really hope that maybe one day we will have like a browser app that just can communicate with WebHID with your hardware wallets. Of course, it's a good and a bad idea because, as you know, most users don't check the URL they are on, so maybe they will open a scamming website and get scammed. Thanks.